Okay, so in number two, it is asking us to determine whether either of these companies' dimensions are best. In other words, determine the dimensions that would minimize the cost of producing each storage container as well as the minimum cost. And so it's asking us to show all of our work, and I divided all of my work into different steps just to make it easier for myself. So according to the work above, we know that Loan Depot's dimensions are better according to the work that I showed here because Loan Depot's costs are lower than Home's. So it's asking us to prove that here. So in the first step of my work, I put what was known and what we wanted. So what was known was that the volume equals x squared times y equals 36. X is the length and width of the square, and Y is the height. So we know that for Loan Depot, it's 36. What we want to know is the minimum cost function. So we took 2x squared plus 4xy squared plus 4x squared, and then that led us to getting 6x squared plus 8xy. In step number two, I isolated y from the known equation, so I just get y equals 36 over x squared, and I plug that into my cost function. So it's 6x squared plus 8x times 36 over x squared, which gives us 6x squared plus 288 of over x, and that's our c of x. And then in step three, we're trying to find the interval, so we take x is greater than 0 and y is greater than 0, and we already have our y equals, so we just plug that in for y. Just 36 over x squared is greater than 0, sorry. And that is true because if you plug in x here, it's gonna automatically, if you plug in something for x, it's gonna be positive. Um, in step 4, we're gonna take that is the calculus step. So this is the step where we find the critical values. And so in order to find the critical values, we take the c of x function and we find the derivative of that. So I ended up getting c prime equals 12x minus 288 over x squared. And so when finding the critical values, we want to see if c prime equals to 0 or c prime does not exist. So for c prime equals 0, we set the derivative equals to 0, and that gives us a critical value of 2.88. And then c prime does not exist. We're just going to set the denominator of 288 to 0. So that's x squared equals 0, which is x is 0. And in the so in the same step, we also take the second derivative of this so we can find the absolute minimum. And so we just take the second derivative of the first derivative, and that gives us 12 plus 576 over x cubed. And then we take 2.88, which we got in this critical value, plug it in, and see if it's greater than 0, and that will give us our minimum, our absolute minimum. So it's 12 plus 576 over 2.88 to the third power, and that is greater than 0 because this ends up being positive. So our absolute minima is at x equals 2.88 feet. So in step 5, this is where we find our answer. So we know that x equals 2.88 feet, and we want to find our minimum cost. So we take our original cost function, and we set x equal to 2.88. So that gives us 6 times 0.288 squared plus 288 over 2.88. And that in total gives us $149.77. And that is how you find your minimum cost. Thank you.